Welcome to We Are Not Scientists. What in the infinite subject of space and science do we have to talk about in this episode? As always, to kick off, LP, as Commander, you get to choose this week's topic of discussion. What will it be?
Well, I thought, Simon, as we live in it, why don't we talk about the solar system?
Let's give it a go. So LP, what is the solar system and where did it come from?
So, Simon, what is the solar system? It's basically a collection of planets, moons, asteroids, and comets that are gravitationally bound to a star known as the Sun. It was formed about 4.5 billion years ago from a collapse of a giant interstellar molecular cloud. And it is located within one of the Milky Way's galaxy's outer spiral arms, the Orion Spur. At its center is the Sun, a 1.4 million kilometer wide yellow dwarf star. In comparison, Simon, Earth has a diameter of about 12,500 kilometers. So it's a pretty big beast.
Can you fit 1 million Earths into a sun? I think I read that stat somewhere.
Yeah, it's about that. Yeah, I think it's because it's about. I think the Sun's about 110 times the size of Earth. So you just keep going up and up in size. So yeah, it's a pretty big beast.
Yeah. So where does it begin then? Where does it end? And like what's in between it?
It's quite a lot of stuff, Simon. But if we go on a quick tour, as we already mentioned the Sun. So at the center of the solar system is the Sun, and then obviously as you start to move out from the Sun, you first come across the four rocky inner planets: Mercury, Venus, Earth, and Mars. These are known as the terrestrial planets, again because they're rocky and you can stand on them. And these planets are well, obviously, the most likely place where you'd find life, because on one of the rocks there definitely is quite a lot of life, and we still have hopes that maybe on one or the other rocks we might prove beyond all reasonable doubt that there's also life on some of those as well. But yeah, it's probably what's known as it's where the planets that exist within what's known as the Goldilocks zone are within our solar system. So where water is allowed to essentially act in its liquid state, not too hot so it doesn't boil away, and not too cold so it doesn't freeze. So that's the inner part of the solar system, Simon.
You're not going to get water on the closest planet to the Sun, are you, LP?
No. Mercury, far too hot.
Hottest planet?
No, it's not the hottest planet.
Ah, damn.
Yeah. So Krystel, I don't know what your servers are telling you, but what have you got as the hottest planet in the solar system?
I've got Venus as the hottest planet in the solar system because of the gas and the gas clouds in the atmosphere. I actually read a description of Venus this morning. Somebody described it as a picture of one of Dante's 7 levels of hell or something like that. It was just the most extreme of the planets and the hottest.
Yes. Yeah, so the reason is, Simon, Mercury doesn't really have an atmosphere. So although it gets very hot on the side that faces the Sun, the side that faces away is very cold. Whereas Venus has a very thick atmosphere, so the whole planet is enveloped in this runaway greenhouse effect, which has superheated the atmosphere. Hotter than any other region in the solar system other than the Sun itself. So there you go.
So all 4 planets there have water?
Yes, probably. Mercury possibly under its surface. Venus, maybe trace amounts in the atmosphere, although most of it's kind of evaporated away. Although there's an atmosphere, generally it's made of nasty things like sulfuric acid and noxious gases. Earth obviously has a lot of water, and Mars is believed to have water, kind of frozen water in its polar caps and under the surface. And there's been images of actually a bit of water sort of venting away into steam because of the low atmospheric pressure on Mars during the Martian summer. But yes, there is a lot of water. There's a lot of water in the whole solar system, actually. It's just in different states. Obviously, the further you go out, it's out there, but it's all frozen solid. So
well, all I can think of is Venus. I've still got that image in my head. I definitely couldn't visit there. I don't think that'd not be on my list of the solar system planets.
no, it's a pretty hostile environment. So.
What would happen if I jumped out of my spacecraft with my shorts and t-shirt on? How long
onto
would I onto the surface? How long would I last?
It's a matter of seconds. I mean, the temperature is up in the sort of 400 or 500 degrees Celsius, hot enough to melt lead. The surface pressure, the atmosphere is so thick. I'm sure it's something like 20-25 Earth atmospheres. So it would be like standing at the bottom of the deepest ocean trench with pressure, and you'd be crushed within a matter of seconds.
5 seconds?
Maybe. It wouldn't be nice.
What about Mercury? How long would I last if I got off my spacecraft in my shorts and t-shirt onto Mercury?
Well, again, it would depend on which side of the planet you were on.
Hot side.
The side, you would just burn probably and incinerate pretty rapidly. If you're on the dark side, then you would just freeze into a frozen chunk.
How rapidly?
Again, you haven't got long in these sort of situations.
10 seconds, 20 seconds?
Yeah, I'd say on the dark side, I mean, maybe you could last, 20-30 seconds.
Right. So Mercury's the best place so far.
It's but yeah, so none of these places really, other than Earth, are particularly pleasant for a bipedal hominid like yourself to walk around without any kind of additional protection.
Oh, I'm offended. I've never been called that before.
So
we're number 3 then, aren't we? So we've got Mercury, Venus, and then we're number 3, third planet from the sun.
Yes, the third rock from the sun. Yes.
I mean, it is the actual sweet spot that for life, isn't it?
Yes, yeah, it is pretty much, as far as I'm aware, pretty much slap bang in the middle of the Goldilocks zone. You have Venus that sits right on the inside of the Goldilocks zone, and you have Mars that sits right on the outside. And they were just, because in the solar system's early history, it's believed that actually Mars had oceans. I mean, there's evidence of riverbeds on Mars now. It would have an atmosphere, and some have even suggested about 1 billion years after the formation of the solar system, Mars and Venus were both far more pleasant places to have lived than the early Earth, which was a lot more chaotic in its atmosphere, and things hadn't settled down on Earth at that point. So it was just later on in the solar system's history that basically Mars lost its atmosphere, and Venus's atmosphere went the other way, and just runaway greenhouse effect.
Isn't there the idea that as the sort of Venus and Mercury and Mars, their inner cores started to settle, and they lost that magnetic field that Earth still holds on to, that protects us from the sun's solar winds and radiation? As those went, that's what stripped away the atmosphere. Am I thinking correctly?
Yes, no, I think Mars, a lot of scientists believe that is the case with Mars. It seems to have, basically, its core seems to have solidified. So as you've just said, there's no like dynamo in the middle like you get with Earth, where you have a molten iron core that's spinning around and creating a magnetic field. And that's, like you were saying, it's that magnetic field that protects the Earth from big solar flares and such. Again, it's why we see the aurora. It's essentially the charged particles from the sun charging through the Earth's magnetic field. So you don't really get an aurora on Mars because, again, there doesn't appear to be any magnetic field left. And whether that's to do with the fact Mars is smaller and its core solidified, it wasn't able to hold on to the internal heat in the way that Earth has. They're not, I don't think they're 100% sure, but yeah, that does seem to be one of the primary reasons that Mars over the years has lost a big chunk of its atmosphere, and now its atmosphere is very thin.
Would you get an aurora on any other planet in the solar system? Would you get an aurora on any of the other planets in the solar system, or is that solely an Earth thing?
No, there are aurora that have been witnessed on Saturn. The Cassini probe took some great photos of Saturn's aurora. Again, even as you move to the outer planets, like the gas giants, also known as the Jovian planets, and these, you can't stand on these, Simon. They are just literally big, huge balls of gas.
So it'll be under a second.
You would just fall into them. You wouldn't ever. I mean, by the time you reach anything that you could potentially stand on, you'd be talking compressed gas. And again,
They're not places for me to get out in my t-shirt and shorts off my spacecraft then.
no, again, Simon, probably common theme here. Really, Earth is likely to be the only place you can kind of get out and have a walk around in your shorts and your flip flops. So yeah, so there have been pictures of aurora taken on many planets in the outer solar system, because they have big. They believe large metallic cores, which again are creating this dynamo effect and creating a magnetic field. So yeah,
It's a fun word, that dynamo.
Dynamo.
Very fun word. Okay, well that's really interesting. I love the aurora, so that's really cool information for me. But before we hit those gas giants, don't we have a bit of a asteroid belt that we've got to get through, or?
Yes, no, absolutely, Krystel. You bang on. Out beyond Mars, we arrive at the asteroid belt, and this seems to be a collection of millions of little asteroids to quite large objects, anything from a few meters across right out to a dwarf planet known as Ceres, which is about 950 kilometers across. And essentially, this appears to be the building blocks of what was left over from the formation of the inner planets that just kind of didn't ever quite settle into another planet. So there's just this kind of ring of debris that just sits, let's say, between the orbits of Mars and Jupiter.
And just like the planets, they're orbiting the sun, right?
Yes. I mean, essentially, the definition of a planet is something that orbits the sun. Asteroids orbit the sun, as do comets. We can come to those a bit later because they come from a long way out. But yeah, all of those objects orbit the sun. Unlike moons. Now this is the interesting thing. Why is a moon, Simon? Basically, a moon is a moon because it doesn't orbit the sun. It orbits something else, which in turn orbits the sun. So our moon orbits us, and then we orbit the sun. So it's
there are a lot of moons in the solar system, eh?
Yeah. I think last count was about 150 that we know of.
You got a favourite?
Oh, do I have a favourite moon? Now there's a question. I'd love the moons of the solar system. There's such a diverse collection of bodies, and in some respects, a lot more interesting often than their host planets, as it were. I mean, we were talking about Jupiter and how you can't stand on the surface, but certainly some of its moons are fascinating.
Can you imagine being shown up by your moon?
Shown up. They're just
unfortunate planets.
As places for humans to visit, I suppose. I mean, Jupiter's got 4 main moons, and it's almost like a mini solar system in one, if you know what I mean. You've got your core planet, and then you've got these amazing celestial bodies that are really affected by Jupiter itself. So the innermost moon of Jupiter is Io. And this moon is covered in volcanoes, and it was a real surprise to the team that sent Voyager 1 past Jupiter back in the late 1970s to see all these volcanoes covering Io. And essentially, what they worked out is Io orbits so close to Jupiter. It kind of and it's not like a completely circular orbit, it's an elliptical orbit. It kind of like squashes and squeezes Io, and it's squashed and squeezed it so much that it's melted the core into basically magma, and you just get these huge volcanic eruptions. And the planet's incredibly the moon is incredibly geologically active, and just fascinating. But again, probably not somewhere you want to really stand because it is raining a lot of hot stuff out of the sky a lot. Yeah, so Io is probably not somewhere you want to spend a lot of time sort of standing on the surface, because you've got a lot of hot stuff falling out of the sky there.
Did you know that Io is the only heavenly body? Is that how you would say it? Is the only body beyond Mars that actually has what we would consider normal volcanoes with magma and molten rock, whereas everything else beyond Mars they have what's called a cryovolcano. So the volcano sorry So the volcanic activity is actually more to do with water and vapor and gas than it is to do with molten rock and lava. So I was also like quite a special little dude because he's pumping out stuff that you're not seeing anywhere else in that sort of farther solar system.
I'm more a Ganymede man.
Ganymede, yes. Well, another one of Jupiter's moons.
Biggest of the moons.
Yes, yeah, biggest of all moons, I believe.
Oh.
System. So yeah, it's not far off the size of Mercury, I believe. But yeah, no, interesting point you raised there, Krystel, about volcanism. Again, our exploration of the solar system with the Voyager craft really made us have to rethink how we thought about topics like volcanism. As you said, volcanism before had always been considered to be melted rock and magma and that sort of thing. But I think it's when they flew past Triton, which is Neptune, the furthermost planet's main moon, that they saw cryovolcanoes. And I think this was essentially solid helium locked up in like helium ice under the surface, and during like the kind of midday as it would be on Triton, it just got high enough to melt that helium into a gas, and then that would explode out from these big geysers or geysers, and then that would rain down on Triton, covering it with sort of like a layer of dusty helium ice. So yeah, no, absolutely fascinating.
Well, it wouldn't really surprise me that Neptune's moon is more interesting than Neptune, because to me that's the most boring planet, Neptune.
Neptune?
Yeah.
I mean, it's known as one of the ice giants. It's blue. It's made primarily of methane gas, I believe. And
you're not selling it. You're not selling it to me.
No. So, and again, it's
not compared to its moon.
Deep cold out there, Simon. I mean, you're minus 200 degrees Celsius out that far.
Well, it doesn't surprise me because it's the furthest away from the sun, isn't it, in the solar system?
Absolutely, and it's kind of you've got to remember, if you actually went to Triton as well, you would really struggle to see anything, because although you'll see pictures of Neptune and Triton and they all look illuminated, you are so far from the sun, 4.5 billion kilometers to be precise. You're so far from the sun would just look like really essentially what is a really bright star in the sky. It would be it's like 60 times darker out there than it is where we are in the solar system.
I mean, don't come down too hard on Neptune. He might look a little bit boring, but he's got a couple of features. You know, he's also got his own dark spot. He's got a big storm similar to the Jupiter's Great Red Spot, which is commonly known as the Great Dark Spot, and is roughly the size of Earth. He's got some things. Neptune spins very quickly on its axis. That's interesting.
Yeah, I believe Neptune actually has the fastest winds in the solar system as well.
Oh, yeah,
thousands of kilometers an hour. So
you not just get cold, you get dizzy as well. That's not nice.
Yes. Yeah, so but I wanted to, if we could just return to the moons, because they're so fascinating, the moons. We talked about what we know and we definitely have seen when we talk about volcanoes on Io. But if we come to the next moon out from Jupiter, you've got Europa. Now this is a fascinating world, and we really hope we can send a probe there. Essentially, it's an ice moon. But this ice seems to be floating on something, and we believe it could be an ocean of water. When Voyager flew over Europa and took pictures of Europa's surface, it saw ice sheets, but they kind of rippled and had these kind of telltale signs that this was ice that was moving, because it looks very similar to the ice when you take pictures of ice of the Arctic from Earth. What they believe is, again, being affected by the gravitational pull of Jupiter, it's caused the core of Europa to melt and created essentially sort of, again, more sort of volcanism, geovolcanism. And they reckon underneath where obviously this warmth is melting this this ice and creating an underwater ocean, we could possibly find things like black smokers that you get at the bottom of oceans on Earth. You know, these big kind of volcanic columns that vent out this hot, noxious kind of chemicals and heat. And this is one of the prime candidates for where life started on Earth, because it's rich in a sort of complex chemistry. Now, if Europa has these kind of things, then there are a lot of scientists that believe if we went down under the surface, we might actually find some kind of life bobbing about, maybe even swimming about. We really don't know how evolution may have taken hold on Europa. So probably one of two of the most exciting prospects of finding some very interesting things to look at in the solar system, Europa. So yeah, all about the moon, Simon.
What's the prettiest planet?
Pluto.
What's Pluto?
It's got a heart. It's so pretty. I love that planet. Little baby hanging out there.
Can I be cruel, Simon? As excited as Krystel is about Pluto,
don't say it.
I just need to bring it back that Pluto is not a planet.
These are lies.
Pluto is a dwarf planet. It used to be a planet. Everybody who went to school in the 1980s and 1990s would have known it as a planet. It was all on all the maps, but it was unfortunately it was downgraded as we discovered more objects out. And this is when we go far out beyond when we go out beyond Neptune, you're getting out to something called the Kuiper Belt, Simon. And this is where Pluto lives. And it lives there with a collection of other dwarf planets. It's not the only one. We found many since the invention of the Hubble and various other probes that have been out. There's Eris, Haumea, and Makemake. These are all dwarf planets. Some are similar in size to Pluto. And again, this is kind of like in the way you have the asteroid belts that kind of creates the perimeter around the inner solar system. The Kuiper Belt creates the perimeter around the outer solar system, as it were. And this is where a lot of comets come from, because a lot of the objects out there, although they might have rock in them, a lot of them are just essentially big chunks of ice. And every so often, something will disturb one of these bodies, and then it gets thrown into the inner solar system. And it's what we then see as comets, and they kind of come in and they go out.
I mean, who made that decision to take away Pluto's planet status? Who has that power to take away?
I'll tell you who.
A planet.
I'll tell you who. Neil deGrasse Tyson. He did it. He's a nasty man.
What was his criteria?
I don't know. Just because he's clever. What I'm really hoping will happen, right? So little side note. When I grew up learning about a dinosaur called Brontosaurus. And then as I got older, people started thinking, well, maybe Brontosaurus wasn't real. Maybe it was actually an Apatosaurus. Somebody got wrong, right? So they said, oh no, Bronto's not a real dude. But now we're bringing it back, and people are saying, actually, we do think Brontosaurus is a real dinosaur. So I'm really hoping that this evolution happens for Pluto as well. Some guy comes along, he poo-poos on Pluto and ruins the dreams of all the children who wanted to go to Pluto. And then, then he's proven wrong, and Pluto's reinstated.
What you need is someone who's like a kid now, getting really into Pluto. They become like a very big space and science expert and astronomer, and they get to reclassify Pluto as a planet.
Well, I don't know. I mean, if I could just come in like Neil Tyson deGrasse, or deGrasse Tyson. I never can remember which way around his name goes. He's a great astronomer, a great scientist, and actually it wasn't just him. It was the World sort of Astronomical sort of Association, and that people had sort of looked at this for years. And even I remember watching Patrick Moore in the early 1980s, and there were even doubts then, because Pluto does some strange things. Instead of orbiting on an elliptical plane of 1 or 2 degrees from one another like the rest of the planets do, Pluto kind of arcs a bit up and out of the solar system and then back down again, which is symptomatic of a Kuiper Belt object. Comets often do the same thing, come in on funny angles and whip back out again. And like we said, we found so many other objects out there. So if Pluto's would be classified as a planet. Like we said, what about Eris or Haumea or Makemake? Now you can't. Now they know that there are countless hundreds of other objects, probably the same size of Pluto, out there that are yet to be discovered.
What about Charon? Charon.
Stop. Charon. Well, Charon's one of Pluto's moons.
I mean, we have to have a planet called Charon, so I think we should get Pluto back in there.
Yeah.
Now, I just found something really interesting, and it says here that the International Astronomical Union downgraded the status of Pluto to that of a dwarf planet because it did not meet 3 criteria. And essentially, Pluto meets all the criteria except one. It has not cleared its neighboring region of other objects. So basically, because Pluto's not rude and he's not kicking out his neighbors, you've downgraded him. Nice guys finish last. That's what I've decided.
Yes.
So going back to my original question, prettiest planet. I think you said that might be maybe the cutest planet, Pluto, Krystel, because you feel a bit sorry for it. But I think my judgment was swayed there with the possibility of Charon becoming a planet. So I'm with you, Krystel, with the Pluto being a planet.
Yes, Team Pluto.
Okay, guys. Yes. Just for our listeners, though, we just have to kind of confirm that as much as Krystel and Simon are very passionate about Pluto, and I also love it as a world and a place that we've visited, it is not scientifically known as a planet any longer. So I'm really sorry about that, guys. But, yes.
Oh well, let's talk about something more positive. The jewel of the solar system, in my opinion, Saturn.
Saturn, yes. No, fascinating world. Again, huge, like Jupiter, but this time with just a beautiful set of rings that go out thousands of kilometers from the planet. Apparently, you could fit sort of the width of the rings. You could fit between sort of just about between Earth and the orbit of the Moon. So you're talking quite a way. But the rings are only maybe a kilometer wide at their widest. Maybe even less. Maybe down to a few meters in certain regions. So yeah, no, absolutely fascinating planet. Again, with its own collection of moons, huge selection of moons. Everything from Titan, which is one of the only other kind of places in the solar system where you have an object with its own sort of proper atmosphere. So it has a liquid. It basically rains liquid methane on Titan. So yeah, no, absolutely fascinating world.
It sounds like a black metal album.
Liquid methane. Yeah. No, but again, like we talked about volcanism and how we had to reconsider volcanism, we've also had to reconsider geology, because whereas you would see rivers carving kind of patterns through mountain ranges as the rivers flow and out to sea, you get the same things on Titan, but instead of it being rivers of water, it's rivers of methane, but it creates the same kind of geology. So again, you see river tributaries and how they flow and lakes and everything on Titan. So yeah, no, absolutely fascinating world. You've then got, we mentioned about Europa. You've got a moon called Enceladus, a lot smaller than Europa, but again, we believe the same thing, core being melted by the gravitational pull of the giant Saturn. A thin icy crust and then liquid underneath, and they reckon this might actually be an easier place to visit, because the icy crust they think is maybe only a few hundred meters thick as opposed to maybe 100 kilometers thick on Europa. So that'd be a fascinating.
How can you talk about moons when we're talking about Saturn, the jewel of the solar system, the second largest planet in the solar system, the ringiest planet in the solar system? It's got it all going for it, and I think it might be the fastest spinning, maybe, if I'm not mistaken by Wikipedia.
No, I don't know if Krystel, if you can fact check that one. But again, Simon, no, it is a fascinating world, and it has this weird hexagonal storm structure on its poles, and we don't fully understand why that is. But again, it's not a world that you could walk on. If you fell into Saturn, again, just like Jupiter, it would not be a comfortable ride, and you'd end up being squashed as you fell deeper and deeper into the atmosphere. So
the two gas giants.
Not a nice place to actually want to visit too close, I would say. Can I just mention one more moon?
Yeah,
one
yeah,
more
yeah.
shout out. And of course, one of my all-time favourite moons of the solar system is Mimas. Only a small world. I think it's only a few hundred kilometers across, but it has this huge blast crater on one side of it, which essentially makes it look very much like the Death Star. So to all our listeners, just type in Mimas into your Google search bar, or other search engines are available, and yeah, just check out Mimas. Just a great little world. It looks like something from a very popular science fiction series.
Well, actually, it looks to me like Jupiter is the fastest spinning planet and Saturn is a close second.
Ooh, the two gas giants, the fastest spinning. Why is that, LP?
I think it's just I don't know. That's the honest answer. I believe the atmospheres again might actually spin faster than the cores underneath. They're not 100% sure on that, but I believe Jupiter, like it's one rotation, it's like 10 hours. It's not a long time.
Saturn the prettiest, yeah, but kind of the two most iconic planets.
Yeah, definitely. They're both, like, when you think of the planets, that's the imagery that you get, isn't it?
We briefly mentioned Neptune, but you've got the ice giants. We haven't even mentioned Uranus because everybody forgets about Uranus. So.
But surely that's the funniest planet, isn't it?
We did mention Neptune.
Yes.
Didn't we? Because I said it was boring.
We did, but not Uranus yet. So
yeah. Well, don't worry, I've got that. What planets can we see from the solar system with our naked eye?
What planets can you see? You can see all of the inner planets. Mercury's hard to see because it's very close to the sun. So it's not often you've got to know exactly where you're looking, right, sort of as the sun is setting or just before its rise. Everybody must have seen a brilliant Venus.
Pardon?
Morning. Everybody must have seen a brilliant Venus.
Oh.
With definitely the word is Venus, so just in case there was any confusion there, either early in the morning or just after sunset. One of the brightest objects we'll see in the sky after the moon and the sun themselves.
Mars is classic, isn't it? I mean, just look, just the red planet. It does what it says on the tin.
Absolutely. And then, of course, seeing Jupiter and Saturn. Beyond that, then we come to Uranus. Now, Uranus, unfortunately, if you want to see Uranus, you're not going to see that with your naked eye, Simon. That's going to take a telescope or a pair of binoculars.
Is that the furthest one you can see then? Saturn.
Saturn's the furthest.
Okay. So you're not going to see Uranus through Saturn then?
You're not going to see Uranus through Saturn. You won't be able to see Uranus without like I say, some kind of optical aid, shall we say?
But it is. I mean, it does win the prize for the funniest planet, doesn't it? The funniest planet, Uranus.
It had an unfortunate name. I tend to try and use the other pronunciation.
It's a bit obvious, though. It's a bit of an obvious joke, isn't it? But it's one of those that you just start the elephant in the room, isn't it? When when people are saying the new word for it, people are thinking of the old word.
But again, it is. But Uranus. Sorry, Krystel.
Isn't it a bit gassy as well? It's a bit gassy planet.
It is. I believe it's the coldest planet as well. Again, very, very cold in its atmosphere. So, but it's also an unusual planet because it actually orbits, it sort of rotates on its side. So one of its poles always faces the sun, I believe, and one's always facing away. So yeah, it kind of rolls around the solar system on its side. If you see what I'm saying, as opposed to kind of be sort of rotating roughly vertical or a few degrees off like Earth does.
I have some interesting facts about the moons of Uranus.
Please tell us.
Okay, and now this is a fact that I learned ages ago, and I don't know why, but it's one of those things that really stuck. So there are two moons. Well, Uranus has many moons, but the two moons, Titania and Oberon, were discovered by a man named William Herschel. And guess where he lived when he discovered them?
LP?
I know he lived in Bath, didn't he, at some point in his life?
He did, but that's not where he was living when he discovered these moons. He was living in the one and only Slough, everybody.
Wow.
What a great astronomical town.
What was the light pollution like then?
Well, I don't know. It was quite an industrial place, wasn't it? But I don't.
It was, but you would have been you probably would have been pre kind of like electric lights, wouldn't you? So you would have probably found that the night sky was a lot clearer to people before sort of the light pollution created by the street.
Yeah, I mean, we're talking 1787, so yeah.
And am I right in saying, Krystel, whereas most astronomical bodies in the solar system are either named after Greek gods or Roman gods or Norse gods, or even, I believe, sort of Maori kind of gods. Actually, the moons of Uranus are named after characters from one of Shakespeare's plays.
Yeah, from A Midsummer Night's Dream. So that maybe that's why I remember that fact all the time. And maybe it's Slough. I think it's probably more to do with Slough. That's why I remember it. Because what a fun word. You don't get names for stuff like that out here in the Arctic, I'll tell you what.
It's a good looking planet, Uranus. I've made my own name up for it there, if you can see. It's kind of between the two. It's got its rings, hasn't it?
It does, yeah.
They were not, when I was a kid, we didn't think that that planet had rings.
No, I believe the rings of Uranus have been known. They have been known for quite a while. They were visible with good telescopes just about before Voyager got there. But certainly Neptune has a very faint ring system, and that we didn't know. That was a discovery when we got to Neptune in 1989, I believe.
Suddenly Neptune becomes more interesting.
Well, you were dissing on the Neptune earlier, but these worlds have so much to talk about. So none of them are boring by any means.
So what? So we're at the end of the solar system. What's at the end then? We got the Kuiper Belt, right? All the asteroids.
Oh, so the edge of the solar system. Where is the edge of the solar system? Now, there's kind of two ways to define this. I think. Now, the first thing to say is how far does the effect of the sun, how far is it felt? When I talk about the effect of the sun, I'm talking sort of essentially about the energy that the sun puts out. Okay. Now the Kuiper Belt, out beyond the Kuiper Belt, is a sphere essentially known as the heliosphere, and this is essentially it's like a pressure. If you can imagine like a balloon, and the pressure from the sun is radiating in all directions. So even though Pluto's out a long way, you still do get solar radiation that actually rains on Pluto. But I think it was Voyager, it was either Voyager 1 or 2, just 2 or 3 years ago, actually passed beyond a point called the heliopause. And this is where Voyager's sensors suddenly noticed a big drop in sort of solar pressure. There's not a lot of pressure out there, but there is still, the sensors on Voyager was able to still sense that the sun, the sun's energy could still be felt. And then all of a sudden, it just dropped off very rapidly and essentially passed into what is interstellar space. Now, we think that's about 15 to 20 billion kilometers out. You reach interstellar space. So that's the kind of bit between the stars where,
which is nothing really when you take into context the Milky Way, isn't it?
No. I mean, it's like a tiny sort of half a millimeter compared to the whole size of the Milky Way. However, so that would be the first definition, and we've already now sent crafts into interstellar space and beyond the outer rim of the solar system. However, there's something called the Oort Cloud, which is even further out. Now, the Oort Cloud is a collection of a little bit like the Kuiper Belt, but instead of being a belt, they think it's a huge sphere around the solar system. But that goes out up to potentially like 3 light years of just old bits of, again, leftover solar system. It's another area they think comets could come from, but it's so far out we know very little about it. So that's another definition for the edge of the solar system.
Can we just say that on the Kuiper Belt, on the furthest out from the ring, that last rock on the asteroid belt, that's the edge of the solar system? Can
we say that?
Yeah.
Again, well, yeah. I mean, that could be the last object, I suppose you could say, within the solar system. Yes, that could be like the the last. It's kind of like, I think when you go down to Cornwall, down to Land's End, you kind of get the first and last pub. It's kind of, although there's a bit of rock a bit beyond, ultimately you're not going to find any more pubs in England if you go any further southwest.
So, LP, what's the future of the solar system?
Future of the solar system. Well, as we mentioned earlier, it was formed about 4.5 billion years ago, and at its center is a yellow dwarf star. Now that star, our sun, is about halfway through its life. It's burnt about half of its usable fuel for a process known as nuclear fusion. Now that will continue, but in a couple of billion years, as that fuel starts to run out, it will start to swell in its size. We see this in other stars as they age, they begin to grow and get bigger and bigger and bigger. And it's believed that that sort of probably 3.5 billion years from now, it will start to swell so big it will essentially boil all of the oceans off of Earth and will probably swallow Earth. Its whole diameter will go out to maybe even Mars. And then it will explode. Probably not in a supernova, because it's not big enough. You need like a supergiant to create a supernova. But it will probably then just kind of retract in on itself as like basically a burnt out ember known as a white dwarf, leaving just, again, both the Earth, Venus, Mercury, and probably Mars would have been destroyed, and maybe a few lonely kind of iced up dead worlds floating around this kind of leftover remnant that was once a star. So a bit sad, really, but we got to.
Yeah, well, thanks for adding to my existential crisis.
You haven't got to worry about it for about another 2.5 billion years, Si. So I wouldn't put it right at the top of your priority list.
Plenty of life in the old dog yet, eh?
Yes.
So you don't think it'll be like that movie Sunshine, where they go and reignite the sun, but then loads of weird stuff happens? I don't want to spoil that for anybody. Very good film. But what do you think? Do you think we could reignite the sun if it decides to go out, or will it eat us before we get to that point?
Yeah, I don't. It's a fun idea in the movie Sunshine, and again, I love the way you see like planets like Venus as you come past. Mercury and things like that as described in that movie. But no, I believe the fusion reaction in the sun is pretty constant, and there's nothing to suggest that it's going to stop anytime soon.
You're such a buzzkill, let's have some fun with this idea. Come on.
I just hit with the facts, guys. I do apologize.
So apart from Earth, obviously our number one, we've not told us, LP, what is your favorite planet, would you say?
What's my favorite planet? Well, contrary to popular belief, I think I'd go for Venus if we're talking about just planets and not moons, and I'll tell you for why. Everybody always says, and I believe Krystel mentioned earlier, that you would hate to go to Venus. It's like Dante's Inferno there. And everybody always goes on about how great Mars is and we should all move to Mars. However, there's been a lot of research done. I believe NASA's run several projects, and they actually believe that Venus could not necessarily be the worst place that humans could choose to live one day. There's a reason for this. And the reason is, although its surface, as we've described, is ridiculously hot and has just such a crazy amount of pressure, it would destroy all organic life very rapidly. If you get up in the clouds above Venus, the pressure starts to drop. And I think once you get maybe 3, 4, 5 kilometers above the surface, you actually get atmospheric pressure about the same as Earth, which is much better than Mars, because Mars has very little atmospheric pressure. You also have a gravity, roughly, Venus is about the same size as Earth, so you can have a gravitational pull sort of up in the clouds about around the same as Earth, whereas Mars, again, has probably half the gravity of Earth. So if you're a human on Mars, your bones are going to start to go all wobbly, and you're not really built to live in a low gravity environment like that. Whereas Venus, you would be fine. So you must have seen the movie Empire Strikes Back, and at the end, Simon, there's the cloud city of Bespin, I believe it's called. Well, I could imagine one day humans living in cloud cities on Venus. The only problem you'd really have to worry about as long as you lived in the clouds, would be the sulfuric acid rain. That could be a little bit burny. So if you had to go outside, you'd probably want to put on some kind of thin protective membrane. I could imagine NASA coming up with some kind of wetsuit kind of thing that's protective of sulfuric acid, but you certainly wouldn't need the full space suit that you would need to walk around on Mars. So I'm just going to give a final big up to Venus about being a pretty cool place if you're not on its surface.
Interesting criteria, very practical choice there from LP. I can kind of see what you're doing. You're kind of cozying up to Venus real estate until there's a time when we need to go somewhere else, maybe.
Yes, big fan.
So Venus, LP, your favorite planet? I think I can guess yours, Krystel. Let's hear it again now.
You know it. It's Pluto. It's Pluto for life.
Nice. The cute one.
The cute one.
As I like to call it.
It is cute.
Venus, the hell one. It's not very good, is it? What would you say it was? Venus.
Dante's Inferno. Yeah.
Yeah.
No,
And then I think mine is Saturn, just because, you know, it's just the most iconic of them all, I think.
It is the ringiest.
It is the ringiest.
Is that a word, Simon? I like it. If it's not, it should be added to the dictionary. I think we've done all right. I mean, of course, we many weeks, months, years about all the fascinating aspects of the solar system, but I think we've encapsulated its main features quite nicely today, Simon.
Okay, so I'm off to book some real estate in Venus. So until next time, it's goodbye from me, and cheers, guys.
Bye-bye.
Bye.